Hi, this is Brian Fogarty, and this is a video for Chapter 7 of the book Quantitative Social Science Data with R, second edition. So in this video, which is the last of Chapter 7, we are going to take a quick look and discuss a little bit about z-scores or z-scores, depending on where you are located. And what we're going to do, we're just going to look at these in R. So z-scores are standardized scores, so they're a way to standardize data. We really should only look at them if we have data that's somewhat normally distributed. You almost never get the case that real data is normally distributed or perfectly normally distributed. But the benefit of it is that it can tell, looking at z-scores, you can tell like where an observation lies, like the probability of lying, of being greater than or equal to some value within a distribution. So it can be benefit. You can also compare multiple different distributions or variables. So it can be useful. So what I want to do just real briefly is look at the data on average SAT scores in universities. So SATs are standardized test in the U.S. that universities use as part of applying to school. I mean, they're used because you have thousands of high schools around the country, and they're trying to compare people who have straight A's at one school to another. So they're standardized tests. There's tons of problems and biases with the SAT, as well as with another common one, the ACT. So some universities are actually getting rid of them. But anyway, they're still fun to look at for data reasons. So I've actually already read this in, but what this has is average SAT scores of 1,278 universities and colleges. And so I do a couple examples in the chapter. Let's just do one example here. What I do as well, should I do this? Yeah, okay, I don't think we can get out of it. Can we get out of it? Sorry, I'm talking to myself. So, the standard deviation function, SD, that's actually for samples. So, this is a population. Now, it's not every university, but we could think of it saying like this is every university. So when it's the population, not a sample of the population, we need to use a slightly different standard deviation. And in the book, I talk about that, include it. But at the end of the day, it's so similar to standard deviation. It's a little silly to go through all of it. So let's do this. Let's cheat. Right? We're going to cheat and do a simple version. We're going to just create these objects. SD, this is going to be SD, SAT, so data, and then SAT average. All right, so again, technically this is standard deviation for the sample. And then let's just do mean. We're going to create an object called mean. It's just mean, SAT, and SAT average. Okay, so let's do this. Let's look up where I went to grad school at North Carolina. And there's various ways we could do this, but we just want to take a gander at the value here. So we're going to do SAT and then the operator, the piping operator. We're going to do filter and then uni double equals and then the name, University of North Carolina at Chapel Hill. Oh, need to make sure it's spelled exactly the same way. All right, otherwise it won't work. Okay, so this shows it has a average SAT of 1402. So the SAT goes up to 1600. I feel like they changed it and then they went back. I don't know. It's been many, many years since I did terribly on the SAT. Okay, so what we want to do is figure out like, okay, that seems good, but is it good? I don't know if that's good. So what we could do is calculate a z-score for this. We're gonna do UNC and then the assignment operator, and then we're going to use the equation that's in the book, which is the value minus the mean divided by the standard deviation, and that will give us a z-score. All right, so we have 1402 minus the mean, and then we're going to divide that by, actually we want this whole, we want to be very clear with this. Oh, I see what I did. Sorry, I'm looking at my notes. I'm going to wrap parentheses around it so it prints, it creates, so that it creates the object UNC, but also prints the value, so we don't have to do it twice. And then SD. There we go. Okay. So in the book I talk about z-scores more specifically. That a z-score 0 is right at 50%. Anything that's negative is below 50%. Anything that's positive is above. Let's look at this. Okay, so we get a z-score here of 2.01. All right, so we can use that to find out what is the probability, like where they lay in the probability. Okay, because we still don't know, right? Like z-score, we're not 100% sure, especially if you're first coming to this. Like, well, okay, great, so it's 2.01. Now what? I'm going to use this function pnorm, which gives us it's for the normal distribution. More technically, it's for a normal distribution. It's the cumulative density function, which is cumulative. You're imagining, right? It's adding up the densities, it's adding up the values. So this is going to tell us where it lies, okay, relative to other universities. So we're just going to put this in here. pnorm 2.01. Okay, so we get 0.977. So this is a percentage. So what we can do is we can say, in terms of how to interpret this, we could say that UNC has a higher or the same average SAT score as 97.8% of other universities in the data, right? Or specific, yeah, that works. So it's pretty high. That means that it's right. So it's greater than or equal to almost 98%. That means there's only 2.2% of universities that have a higher average SAT. Anyway, it's kind of fun to look at. I don't know. Let's see if we can. Let's eyeball. Let's pick a random university. These aren't ordered in any way, so I'm just scrolling. I don't even know. What do you think? Let's see. I was going to say Duke. Duke's going to be really high. Be useful. Oh, actually, let's do this. So what we can do here, I usually don't do this point and click stuff in RStudio, but let's point and click at that. All right, so we just ordered it alphabetically. Let me see. I know what I'm looking for. Okay. Let's look at North Carolina State. That's one of the rivals of North Carolina. But you can see, right, like see how it's phrased? Like people usually refer to it as NC State or North Carolina State. Here it's in the data as North Carolina State University at Raleigh. So it's like very specific that is the campus. So if we just put in North Carolina State, actually let's try that. I'm gonna put in here let's see what happens. It shouldn't work. I haven't tried this. It's on the fly. North Carolina State University. Right. See, it says like there's nothing here. So we need to put in, was it at Raleigh? Is that what it was? Yeah. At Raleigh. Okay, so it's 1349. So it's only slightly below Carolina, North Carolina. Put that in. NC State. And let's do so what is it? 1349. Okay, so we get a z-score of 1.61. Let's put that into the pnorm function, 1.61. Okay, so it's 94.6. So NC State has a higher same average SAT score as 94.6% of the universities in the data. All right, so that's it for this video. It's just kind of putting z-scores into action. Whether or not you actually use z-scores will really depend on the data that you normally work with. Some data lends itself, some data, and probably most data, it does not. We need to run our markdown file, or knit it. Let's click on that. I jumped the gun. Okay, so it ran through, no errors. All right, so it gets it spit it out. Okay, so we see here again we have this knitted document. Okay. All right, so that's it. Thanks for watching, and I'll see you next time.